Equations can be solved in many ways, but one of them is to use the process of factoring and what's called the zero product rule. The zero product rule says that if you have two or more factors, and I'm going to say A times B, two or more factors that are equal to zero, then for this statement to be true, at any given time, either A has to be equal to 0, or B has to be equal to 0 in order for you to multiply these together to get 0. Here's how you're going to use that. If you had an algebraic equation that you were trying to solve that was on one side in factored form, and it had an equal sign, so it was an equation you were trying to solve, and it was equal to 0, then by this zero product rule, we're saying that either this x plus 3 has to equal 0 for this to turn out, or x minus 5 has to equal 0. So what we do is we take those factors, we set them equal to 0, and we solve these linear equations very simply. I'm going to show the steps, but by now you're not even showing that work. I'll subtract 3 from both sides, and I see that a negative 3 will work in this equation. Over here I'm going to add 5 to both sides, and I see that 5 will work in this equation. If you go back here and check each of these one at a time, when you put a negative 3 into this binomial here, a negative 3 plus 3 is 0. I don't care what happens over here. 0 times something is 0. When you put a 5 into this original equation, I don't care that this is going to be equal to 8. Right here, 5 minus 5 is 0, and 0 times anything is 0. These two answers, x is 3, and x is equal to 5, are two solutions that work in this equation because of the zero product rule. Applying the zero product rule to this problem, already in factored form and set equal to 0, just means letting 3x plus 5 equal 0, and letting 4x minus 7 equals 0, and taking these two linear equations and solving them for x. In this case, I'll subtract 5 from both sides. Again, you don't need to show these steps every time, but since I've not done this in a video form prior to this, I'd like to show them. And then to solve for x, we'll divide both sides by 3, and one of our solutions for x is a negative 5/3. The other one over here, when we add 7 to both sides, and we have 4x equals 7, and then divide both sides by 4 to get x alone, the other solution for x in this problem is 7/4. Again, x equals a negative 5/3 and x equals 7/4 are the two solutions to this equation that will make it equal to 0. Unlike the last two problems, I typically wouldn't give you the equation already in factored form and then let it equal to 0. So what you're going to have to do to solve these problems is you're going to have to look at and make sure that everything's on the left side, or one side, and 0 is on the other, and then you're going to have to attempt to factor what is on that one side. In this case, this is a trinomial with a 1 in front of the x squared term. So this is a simpler trinomial to factor. I know that I need an x in the front of each of these. I now need two numbers whose product is a negative 21. So one's got to be positive and one's got to be negative. Those two numbers have to add to be a positive 4. They appear to be 7 and 3. It looks as though the 7 will have to be positive, the 3 will have to be negative in order for those two to add to be 4. It's now in factored form, and I can use the zero product rule. In other words, I can state that x plus 7 has to equal 0, and x minus 3 has to equal 0. And when I subtract 7 from both sides here, I'll get x equals a negative 7. And when I add 3 to both sides to get x alone here, I'll get x equals a positive 3. Those are the two solutions that work into this equation. If I were to check them, and I'm going to attempt to do that maybe over here, let's put the 3 in anyway. For x, I will take 3 and square it, plus 4 times 3, minus 21, and I want to know if that equals 0. 3 squared is 9. 4 times 3 is 12. We're using order of operations. 9 plus 12 is 21. 21 minus 21 does equal 0, and it checks. I can do the same thing with the negative 7. I'll leave that for you to do on your own. These two solutions should go back into the original equation, and they should check. If I ask you to solve an equation, and the equation is not set up where all the terms are on one side and 0 is on the other, you need to make that happen. You can't use the zero product rule unless you have 0 on one side. In this problem, I've got 7x squared equals 9x. I'm going to subtract 9x from both sides so that I have 0 on the right and all the terms on the left. I'm going to transpose. I'm not going to show that step. Basically, when I take a term from one side and move it to the other by subtracting, in this case, that from both sides, this comes over to the left with a minus sign in front of it. I now am ready to factor this because I have 0 on one side, and to begin with, I need to take the greatest common factor out, which is an x. Remember, my broken record, that is always the first step in factoring. Having done that, this is two terms. So what I'm wondering is it the difference of squares? Well, while I can take the square root of 9, I cannot take the square root of 7. I cannot do anything further with this. This is not the difference of squares, and also the variable x is not raised to an even power. I'm done. This is in factored form. The two factors, think of a multiplication symbol there, are x. That has to be set equal to 0. And in other words, one of my solutions is x is 0, and the other one, 7x minus 9, has to be set equal to 0. So I will add 9 to both sides, and I'll have 7x equals 9, and then I'll divide both sides by 7, and I'll have my other solution, in this case, 9/7. So again, this problem has two solutions, x equals 0 and x equals 9/7. You can even look at this and see that the 0 will work quite well in this problem, because when I take 0 and square it, I get 0 times 7 is nothing, and 9 times 0 is 0 as well. Likewise, when I put 9/7 and square it to the left side, and 9/7 times 9 on the right side, those will check. Again, this problem is not ready to factor yet because I do not have 0 on one side of the equation. I'll show the step this time. I want to add 10 to both sides. I'm going to kind of lean it to the right a little bit here so that I will have nothing on the right hand side, and on the left I'll have the 2y squared plus the 12y plus that constant of 10. I'm ready to factor this. Remember, the first step in factoring is to take the greatest common factor out first. So I'm going to factor a 2 out of this expression, and that's all I'm going to do. When I do, I'll have a y squared plus 6y plus 5. I'm ready now to take a look at this trinomial and see if it can be factored. It is a trinomial with a 1 in front of the squared term. That's nice. I can put a y in the front of each of these binomials, and I'm now looking for two numbers whose product is 5 and sum is 6. That's going to have to be a positive 5 and a positive 1. Bring your 2 down. The zero product rule says to take each factor. Now there are 3 of them here, a 2, a y plus 5, and a y plus 1. It says take each factor and set it equal to 0. Well, if I were to set 2 equal to 0, number 1, it's meaningless. It's not a true statement. And number 2, it does not allow me to solve for one of the variables. I don't need to use that as part of my process of solving this equation. However, the y plus 5 does need to be set equal to 0, and the y plus 1 as well. And in this case, I'll subtract 5 from both sides, and I'll get a negative 5 as one of my solutions. Here I'll subtract 1 from both sides, and I'll get a negative 1 as one of my solutions. And these are my 2 answers to this equation. You may have noticed that we've been getting 2 answers. When an equation has a variable raised to the second power, there are always 2 answers, and for us it's going to always be 2 real answers. There will be times when imaginary numbers will be involved. In introductory algebra that will not be the case, but in intermediate it will.